Welcome back to Let's Make a Game, a channel about making computer role-playing games using the free program Twine and the Sugarcube format for Twine. In this video, I would like to keep talking about making games using text input instead of links, and more specifically, I would like to talk about adding a drop command, which allows the player to get rid of items, and I would like to talk about giving special text messages for specific circumstances. So let's do the second one first, the special text messages. As usual, we start in the southwest corner of the mansion, and let's say that we go east and then north. Now, if you've been following this series, you might notice there's a change. It says, as it did before, you are in the northeast corner of the mansion, but now we see there is a door in the north wall, and we see that the exits, as well as going south and west to other parts of the mansion, also go north. But if we choose to go north, we see that you try to open the door, but discover that it's locked. And we will also see that from the list of exits, north has disappeared, and now there's only south and west. So let's say we go west, and we see the key. You'll notice that I've, instead of having the word key in bold, because I felt that that was a little bit difficult to see, I have it underlined now, and I'm not sure whether that's that great, because it sort of might give the impression that you're meant to click on it because it looks a bit like a link. So I'm not really sure what to do about that, but because I wanted to, as I said in the last video, I wanted to highlight the word that you use to manipulate the item, because it's called an elaborately wrought golden key, but you don't have to say pick up the elaborately wrought golden key, you just have to say get key or pick up key in order to use it. So I wanted to have some way of sort of emphasizing the sort of relevant word, and I didn't want to use different colors, because then if someone's colorblind, they'll miss that. So, but I found that bold it wasn't all that noticeable, and I think key has the problem that it looks like a link. So, if you have any ideas, let me know in the comments. I'm a little bit sort of unsure what to do about that, but anyway, continuing. Let's say we get the key, and we pick it up. If we look in our inventory, we can see that, yep, the key's in there. And let's say we go east, and there's a door on the wall. We try to go north again. You go, well, the door is still locked. Games of this type often have this sort of snarky, sort of semi-humorous kind of message. I don't know if you like that style or not, but it's quite common to games of this type anyway. But let's say that we, for some reason, decide that the key is not the way to unlock the locked door, and we decide, well, it can't be the key, we'll get rid of the key. Well, now we can drop key, and now the key is in the current location. And as such, we can pick it up if we want again, and drop it again. So I'm going to spend the rest of the video talking about how I programmed that specific message about about trying to go north when the door's locked, instead of just saying you can't go that way, how it gives you a specific message, and how I programmed the drop command. And then in the next video, I would like to talk about using the item, because obviously if we have this key and if there's a locked door that we need to progress further, we'll use the key to unlock the door. But we'll deal with that next video. Let's have a look at the special message first. So what I did with that, and I'll just zoom in a little. Okay, so what I did with that is I had a special Now, if we were going to have a big game, and if we were going to have lots of locked doors, you'd probably have a system for all of the different locked doors. You probably wouldn't program each one separately, because that would be an enormous amount of work, because they probably all work in much the same way. You'd have a specific page which was dealing with locking and unlocking doors. But because there's only one so far, I've currently treated it as a sort of a one-off thing, and then if we expand the game to have more locked doors, then I'll demonstrate how you would deal with that. But for now, there's only one of them, and I have a special variable which is U for unlocked, I guess, and there are three possible conditions, which is it starts at 0, and 0 is that the player hasn't tried to leave that way yet, so it will still display that there's an exit to the north. Number 1 is that the player has tried to leave that way, and so they know that the door is locked, and so that means that if they leave to the north, you get the message the door is still locked, which obviously you don't want if they're only just discovering that it's locked. And then if $U is equal to 2, then that indicates that the door is unlocked, which means that the player actually can leave to the north. And of course, we can't yet set U to 2 because I haven't yet programmed unlocking the door. But that will be next video. So we'll be dealing with these two possibilities, that U is 0, which is it is at the beginning, and U is 1. So what we do is, when we're in the move page, there is a couple of sort of special cases that only come up if $L is equal to 3 and $Y is equal to 1 and $U is equal to 0, then one set of code comes up. And there's another set of code that comes up if $L is equal to 3 and Y is equal to 1 and U is equal to 1. Now, L is the player's current location, and if L is 3, then they're in the northeast corner of the mansion. That's the one that's relevant. It's the one that has the locked door. Y equals 1, it means that the player is trying to go north, because Y is the variable that remembers which direction the player is trying to go, and 1 is north, 2 is east, 3 is south, and 4 is west. And then U is the special variable that we're introducing in this video, and U equal to 0 means that the player hasn't yet tried to go through the north door. So in those circumstances, if all of those are true, we change $P31 to be equal to 0. Now you'll remember that $P is the array that gives the descriptions of the rooms and then also the exits from those rooms. So P31 is related to going north from location 3, and it's currently set to 5, which means that it's displayed as being an exit to location 5. Although there's other code that stops this happening, which we're currently dealing with. But when you're in location 3 and the program prints out the exits, it will print an exit to the north, because if there's a door in the north wall, you would expect that the game would tell you that there's an exit to the north. Now, of course, we know, because I've just told you, we know that it's locked, but if you're playing the game for the first time, you wouldn't know that the door was locked. And if there was a door in the north wall, but then you looked at the exits and north wasn't one of the exits, that would seem quite strange. So we want to start it with a number in here. It doesn't really matter if it's 5 or anything else, but I just set it up to B5 because that's the one that it eventually will be. So it sets that particular slot in the array to 0. In other words, it tells you, well, actually there isn't an exit there. You thought there was, but there wasn't. And it gives you the message, you try to open the door but discover that it's locked. And we set u equal to 1. And that means that next time, if we come to this room and try to go north again, then this code will execute because L will be equal to 3 and Y will be equal to 1. We're in location 3 and the direction we want to go is north. And U is equal to 1 because of this. And we get the message, the door is still locked. And then changing location, well, that's within an else if. So if this has activated, even though this would be true, because P3, 1 would be equal to 5, and obviously 5 is greater than 0, well, this doesn't execute because this one has already executed. So that's why we can put 5 in this array. We can put this, where is it? Yeah. We can put this value there, but the player still doesn't get to go there, and they won't get to go there until they've unlocked the door, and that's set up a new exit, which is what we'll be dealing with in probably the next video. So that's how you do, well, that's an example of how to do special messages. So instead of just saying you can't go that way, it says the door is still locked, or in the first time you do it, you try to open the door but discover that it's locked. And these little snarky messages are a kind of big part of games like this. You often get particular messages if you try to do something that either that doesn't make a lot of sense or is a bit weird. If you try to, if there's a let's say an urn or something, and you try to go inside the urn, sometimes people will program a little message that says, you're a little bit big to go in the urn or something like that, some sort of slightly mocking little message. And discovering these messages is sort of part of the fun of games of this type. But anyway, that's an example of special messages. Let's now deal with dropping. So we've already dealt with how it goes through the string that the player enters and looks for sequences of text that are in the C array, which is this one. I've added drop as one of those, so it's in place 1, 2, 3, 4, 5, 6, 7, 8, and in process action we have a new possibility, which is if y is equal to 8, then we include drop. Drop, of course, being, and again, drop is divided into drop and drop 2 because, drop isn't divided into the code that deals with dropping items is divided into drop and drop 2 because, as you'll see, I found it a little bit easier to display it that way, even though I could have put it in one page. As with get and get 2 in the previous video, I could have put those on one page, but decided it was just easier to explain in 2 pages and easy to see what's going on. So this is very similar to getting an item. We first need to see if the player has specified an item, because if you just say drop, you as the player, if you just say drop, well, there might be several items and it's not obvious which one you mean. But so first we need to go through every possible item. Well, at the moment there's only one, but we go from 1 to $i.length minus 1. In other words, we go through the I array. And then if replacing the name of that item, which is IZ0, with sort of XXX, if that changes the string, in other words, if the string X includes the name of that item, or the short name of that item, so key rather than an elaborately wrought key, then we set y to be equal to the number of that item. So in other words, if the player has entered the text key as well as the text drop, because we know they've entered drop because they wouldn't have ended up on this page otherwise, then we set y equal to the number of that particular item. So we go through all of the items. If y is still, I didn't mean to, there we go. If y is still equal to 0 after that for loop, then the computer can't find any item that the player is referring to, and so it says, well, what do you want to drop? And then goes back to input. In other words, it doesn't do anything, it just sort of gives an error message. Otherwise, we go to drop 2. So if we make it to drop 2, that means that the player has specified an item, and now we need to find out whether the player has that item, because of course if you say drop key but you haven't yet got the key, well, that's, you wouldn't want the computer to enact that, because that would be sort of weird, it wouldn't make sense. So we need to go through slot B in a very similar manner. We do a for loop from 1 to m, which is the maximum number of items the player can carry, currently 4. And if the zth slot in $B is equal to y, is equal to the item that we're talking about, then we set w to equal that slot in the B array. So again, if w equals 0, well, we can't find that item, so let's give them an error message. Let's give them the same sort of message, which is what do you want to drop? Otherwise, let's drop the item. And dropping the item has two elements. We have to set the location of that item to be equal to the player's current location, because if we drop an item, well, the item is in the room that we're in, we the player. So we go to $i, $y, which is the number of the item that we're talking about, 2, which is the location of that item, and then we set that equal to $L, which is the current location, and then we set the relevant slot of the backpack array, B, $B square bracket $WN square bracket, we set that equal to 0, so the player no longer has that item. So having added, and either way, we either end up giving them an error message or we end up dropping the item. Either way, we end up going back to input, because as with which is what we do with every command. Every command is going to be a cycle of the player enters something, the computer processes it to see what command it is. Based on that, it goes to move or drop or inventory or get or other ones that we're going to add. It makes the relevant changes if there are any, or it gives a message. The message might, to the effect of, well, I can't work out what you want me to do, and then it goes back to input. So that is the basic sort of cycle of the game. It looks a bit complicated and all over the place, but it's actually quite simple. It's initialize, and then from there it's input, process action, one of these, and then back to input. And next video we'll be looking at how you can use items. So specifically how we can use that key to unlock that door, and other things we can do with items. So I hope that's useful or interesting to at least some of you, and I hope you will tune in next time.